Okay, so I know it says geometric sequence at the top, but I really need to change that little typo. Probably because I'm guilty of a little bit of cutting and pasting, but we're talking about geometric series. Now, they are geometric, so you're still going to have a common ratio, R. You're still worried about the first term, but now in a series, we're not interested in the next number in the sequence. We're looking at adding up a certain number of terms of that sequence. Again, there is a finite and there's an infinite. Finite would be 3 plus 6 plus 9 plus 12. So the first 4 terms, add them all up. So that would be something like S with little 4. So add up the first 4. Infinite, that's just, dot, dot, dot. It kind of keeps on going forever. Don't know if we'll really focus a lot on infinite. You might see them in the future somewhere else. But for us, we're more worried about the finite series that's geometric. So here's your formula. It's the sum of the first so many terms in a finite geometric sequence. You need the common ratio. You need the first term just like before. So here's my sequence. It's 2, 8, 32, and 246. So I need to figure out R, which is 4, because I'm multiplying all by 4 to get to the next one. I need the first term, which is 2. And now what I'm going to need to do is a little notation. I'm going to put S with a little 10. And that little 10 is because I'm trying to add up the first 10 numbers in my sequence. So, big old parentheses. Outside is the first number, which is 2. 1 minus 4 to the 10th power. 1 minus 4. Now, I would use a calculator to figure that out on its own, then divide by -3, and when it's all said and done, multiply by 2. Be careful. Do not take the first 2 and try to subtract them. It's not going to be -3 to the 10th power. Remember your order of operations. Please excuse my dear Aunt Sally. So I'm going to go 1 minus 4 raised to the 10th power. Okay. Divide that by a -3. I guess I was gonna 1 minus 4 to the 10th. Okay, divided by a -3. And then times 2. And I get 699,050. And that would be the sum of the first 10 terms in this geometric sequence. Now, these can get really big because, again, it's exponential growth. You're trying to bottle together a bunch of really big numbers. But, Mr. T, it says that it's got ... so it's infinite. Well, it's not because we're cutting it off at the first 10 sequences. And we can find the sum of those first 10 without actually figuring out what those first 10 numbers are. Okay, so geometric sequence, I got 1 times 8, all right? So R is 8, A1 is 1. Now the sum of the first 8. So again, I'm going to make sure that I take the numerator. I'm going to go 1 minus 8 raised to the 8th power. Okay, divide by a -7. Okay, times 1 is not going to change anything. The sum of the first 8 numbers are 2,396,745. Again, gets really large because you are dealing with exponential growth. Okay, well, suppose that you're working for a company that says they're going to pay you 1 cent on the first day, 2 cents on the second day, 4 cents on the third day, and so on. So each day they're going to double your wage. What would the total income be after the first 10 days, 20 days, and third days? Well, here we go. We've got a rate of 2 and our first number of hats. So let's go sum of 10 sum of 20, the sum of the first 30. Okay, so let's take, there we go, first term, 1 minus 2 raised to the 10th over 1 minus 2. Now, if we were doing this class, what I'd do is I'd say, hey, how about some of you do the first one, some of you do the next one, so forth. But I'll do them all here just so you get an idea of what happens. Okay, so the first one, if you are doubling it after getting paid a penny on the first day, so 1 minus 2 to the 10th divided by -1 times 0.01, you would have $10.23. Okay, 1 minus 2 raised to the 20th. Okay, divide that by -1 times 0.01, and you would have $10,485.75. Okay. Now, after 30 days, 1 minus 2 to the 30th, okay, times 0.01, and we've got 1073741.8.23. So you're essentially making $10 million if you take that deal and they double your wages after the $30. And that's why the whole thing is, would you take a penny and then double it every day, or would you just take the outright like cash? And it's usually less than $10 million. Well, the answer is you take the double money, which is exactly what I like to do right now. So this is geometric sequence and series. As far as the formula, if it says S, you're summing them all up. When it says A, you're finding a specific term, and hopefully that helps out and keeps those two separated.